Welcome to NSG 315 Study Session 1 Anatomic and Physiologic Overview of the Heart. Introduction. In this study session, you will be learning about the anatomy and physiology of the heart. The heart is a muscular organ in humans which pumps blood through the blood vessels of the circulatory system. Blood provides the body with oxygen and nutrients and also assists in the removal of metabolic waste. Learning outcomes for study session 1. At the end of this study session, you should be able to discuss the anatomy of the heart, highlight the functions of the heart. Anatomy of the heart. The heart is a hollow muscular organ located in the center of the thorax, where it occupies the space between the lungs, that is mediastinum, and rests on the diaphragm. It weighs approximately 300 grams. Although heart weight and size are influenced by age, gender, body weight, extent of physical exercise, and conditioning and heart diseases. The heart pumps blood to the tissues, supplying them with oxygen and other nutrients. The diagram of the human heart is shown below. Let us consider some of the functions of the heart. Below are some of the functions of the heart. 1. Cardiac electrophysiology. The specialized electrical cells of the cardiac conduction system methodically generate and coordinate the transmission of electrical impulses to the myocardial cells. The result is sequential atrioventricular contraction, which provides for the most effective flow of blood, thereby optimizing cardiac output. 3. Physiologic characteristics of the two types of specialized electrical cells, the nodal cell and the Purkinje cells, provide this synchronization. Number 1, automaticity, that is, ability to initiate an electrical impulse. Number 2, excitability, that is, ability to respond to an electrical impulse. Then lastly, number 3, conductivity, that is, ability to transmit an electrical impulse from one cell to another. The sinoatrial node, that is the SA node, referred to as the primary pacemaker of the heart. It is located at the junction of the superior vena cava and the right atrium. The SA node in a normal resting heart has an inherent firing rate of 60 to 100 impulses per minute. But the rate can change in response to metabolic demand of the body. The electrical impulses initiated by the SA node are conducted along the myocardial cells by the atria via specialized tract called intermodal pathways. The impulses causes electrical stimulation and subsequent contraction of the atria. The impulses are then conducted to the atrioventricular node. The AV node, that is located in the right atrial wall near the tricuspid valve, consists of another group of specialized muscle cells similar to that of the SA node. Number 2, cardiac hemodynamics. An important determinant of blood flow in the cardiovascular system is the principle that fluids flow from a region of higher pressure to one of lower pressure. The pressures responsible for blood flow in the normal circulation are generated during systole and diastole. Cardiac cycle dynamic. During one heartbeat, The ventricular diastole, that is relaxation, and ventricular systole, contraction, occur. During diastole, the ventricles relax, the atria contract, and blood is forced through the open tricuspid and mitral valves. The aortic and pulmonic valves are closed. During systole, the atria relax and filled with blood. The mitral and tricuspid valves are closed. Ventricular pressure rises, which forces open the aortic and pulmonic valves. Then the ventricles contract and blood flows through the circulatory system. Events of cardiac cycle. The cardiac cycle consists of the following 5 events. 1. Isovolumetric ventricular contraction. In response to ventricular depolarization, tension in the ventricles increases. The rise in pressure within the ventricles leads to closure of the mitral and tricuspid valves. The pulmonic and aortic valves stay closed during the entire phase. Number 2, ventricular ejection. When ventricular pressure exceeds aortic and pulmonary atrial pressure, the aortic and pulmonic valves open and the ventricles eject blood. Number 3, isovolumetric relaxation. When ventricular pressure falls below pressure in the aorta and pulmonary artery, the aortic and pulmonic valves open. All valves are closed during this phase. Atrial diastole occurs as blood fills the atria. Number 4, ventricular filling. Atrial pressure exceeds ventricular pressure, which causes the mitral and tricuspid valves to open. Blood then flows passively into the ventricles. About 70% of ventricular filling takes place during this phase. Number 5, atrial systole, known as the atrial kick. Atrial systole, coinciding with late ventricular diastole, supplies the ventricle with the remaining 30% of blood for each heartbeat. The figure below illustrates the cardiac cycle. Summary of study session 1. In this study session, you've learned the following. 1. The heart is a hollow muscular organ located in the center of the thorax, which occupies the space between the lungs, mediastinum, and rests on the diaphragm. It weighs approximately 300 grams. Although heart weight and size are influenced by age, gender, body weight, extent of physical exercise and conditioning, and heart disease, the heart pumps blood to the tissues, supplying them with oxygen and other nutrients. Number 2, below are some of the functions of the heart. Firstly, cardiac electrophysiology, and lastly, cardiac hemodynamics. Thank you. We've come to the end of this study session.